The ability to create safe and collision-free toolpaths is a central part of driving 3 and 5-axis CNC machines. While safety is extremely important, it is equally desirable to minimize the amount of time and effort needed to produce safe toolpaths. That's why Autodesk PowerMill offers new controls to help identify, manage, and avoid potentially hazardous machine motion. Let's start by considering the machining of this 3D mold tool. This toolpath was created with auto collision checking switched on. Any sections of the toolpath that could cause a collision involving the tool, shank, and/or holder have been removed as part of the calculation. While this option produces a safe toolpath, it also removes sections, meaning areas of the model will not be machined. This unmachined stock will need to be removed using a different strategy. Let's see how PowerMill's improved collision management tools can help. We'll start by cloning the original toolpath and accessing the automatic verification section of the toolpath interface. Note a new option called Keep Colliding Sections. By default, this option is turned off, meaning colliding sections are removed as part of toolpath calculation. However, if this option is activated and the toolpath is recalculated, we can see the entire toolpath is produced, including the colliding segments. To aid visualization, these segments are displayed in a different color. We can learn more about the collisions by accessing the Colliding Sections form, located in the Home tab on the ribbon. The form is divided into 3 sections that can relate to cutting moves, leads, and links. We can see a list of colliding sections that are displayed. Double-clicking one of the collisions causes PowerMill to attach the cutting tool to the toolpath at the point where the collision is occurring, making it easy to interrogate the collision in more detail. As we can see, the tool holder is colliding with the model. On a 3-axis machine, we would typically avoid these collisions by increasing the tool overhang or choosing a different tool assembly. Making sure that the colliding sections form remains open, we can access the tool settings and change the overhang. Note that the colliding sections change color and the form updates to show these collisions have been removed. Alternatively, we could use PowerMill's Replace Tool command to choose a more appropriate tool assembly. The toolpath still includes some small areas where collisions remain. A longer tool would be impractical here. A better approach would be to exploit the flexibility of a 5-axis machine and tilt the tool away from the collision. We'll achieve this by using PowerMill's dynamic machine control tools. We'll begin by sketching a polygon around the region of the toolpath to be modified. This is simplified as the colliding areas are displayed in a different color. Next, we attach the tool to the toolpath in this region and use the grab handles to dynamically adjust the alignment of the cutting tool. Once done, we can define smoothing settings and update the toolpath. Note that the toolpath sections have changed color and the colliding sections form has been updated to confirm that all collisions have been removed. Let's look at an alternative method of working. Here we'll start with a toolpath that has been calculated with automatic collision checking and collision avoidance switched off. We can see that the toolpath safety status is unchecked. We'll check the toolpath using the toolpath verification command. We deactivate the toolpath splitting options, define the necessary shank and holder clearance values, and then click Apply. PowerMill identifies the colliding sections and displays them in a different color. As before, we can now use any of the powerful toolpath editing tools to modify the toolpath and remove the collisions. If a situation arises where colliding toolpath segments cannot be made safe, PowerMill provides tools to delete the sections or split the toolpath. The delete option allows one or more colliding toolpath sections to be selected and removed. The split option works by creating two copies of the toolpath. The first copy includes the safe parts of the original toolpath. The second contains the colliding sections only. The improvements made to collision checking within PowerMill help to reduce the time and effort needed to generate 3 and 5 axis toolpaths to safely and fully machine parts